Okay, so welcome to this final video where I am going to teach you how to move from SPSS to Excel. So first open the tables file that I uploaded because this is over here on the right, because you now only need to focus on the yellow part. You need only to touch the yellow part. Do not touch the white part, only yellow, okay? So that's where you are going to work in yellow. So the first thing that you have to do is to, here below AI, you need to write your um, dependent variable. So I will assume that I have professional aspirations. I will just assume that. So pro, I will write it in here. And then below the other ones. So it depends if you have locus of control are your important variable, then you start with loc and then the others there. But I will assume that I have professional aspirations, so it will be professional aspirations and then sustainability awareness, technology literacy, locus of control, and skepticism. What you need to do is to put the data from here in here. So the minimum of professional aspirations, 4.8, maximum is 10, mean is 7.5380, standard deviation 1.3221, right? So just copy these values in here. Very simple, minimum, maximum, mean, standard deviation, very simple, not a problem at all. And remember, I have this from descriptive statistics. I just had to go a little bit high in my outcome in my output file because I did many regressions. So I just had to go back a little bit until I found descriptives here, and it's next. Then so finish this, and then move to correlations in here. So correlations, you have to report the correlations of your variables, but we need to be very smart in here because if you see here in SPSS, we have AI against AI, and of course the correlation is perfect. AI and AI is 1. So as you can see, there is a diagonal of ones all over here that we don't need to report. So that's why I only focus on the down part of my triangle, like in here. And I will report only the yellow ones because the other ones, this is like a mirror. Professional aspirations and AI is the same as AI and professional aspirations. So there is no point on reporting twice. I will only focus on the part at the bottom. So professional aspirations and AI. Here, be careful because you need to make sure that the order in here in the table is the same as the order that you have in here. If you did everything right, it's supposed to work. So for professional aspirations, how you click, it should be like this. If you are ESA, you should have a different order, but just double check that you have the right order. So professional aspirations with AI, the number that you have to put in here is the Pearson correlation. So it should be 0.202, like this. Then the next one, the one below, here we have the first star. We have star 0.05. So use this apostrophe here, click on the apostrophe, input that with your keyboard, the apostrophe, and do 0.260 and the star. If you don't put the apostrophe there, it's going to give it can give you a problem, especially when you have a negative one. For example, gen and AI, this one here. If you don't have the apostrophe, you will write minus 0.231. I know it works. I think the problem is when you have a negative one with a star. So like this one, uni and age. So uni and age. If you write without the apostrophe, minus 0.314 and 2 stars, because that's what we have in here, uni and age. If you click, you get a mistake, an error. So when that happens, you add the apostrophe. So add apostrophe when you have negative and you have stars. So Not necessarily all the time, but if you get a mistake, it's because you need the apostrophe. So that's it. I think that's you, I mean, it takes time. It's a bit boring task to do. I mean, take 10 minutes. So you just have to be careful at the Pearson correlations with the stars all over here, and then move to regression. Regression. Let's move here. So now I will assume where is the regression here is if professional aspirations is the main my main variable, my first model should look like this, right? Only professional aspirations is this model. So I will show you how to add, how to fill in the data. I think it's important to start with the test that we did. So the first thing that we did is the F value, this model fit in the ANOVA, this one here. We needed to check that this is less than 0.1. So what you need to put in here is the F, 2.931, and then you need to add one star. Why one and not two? Or how many, yeah, one star. This is because significance is 0.09, so it's less than 0.1, which that's what we wanted, but it's not less than 0.05. Otherwise, it would have been two stars, so only one star. Write it like this. Adjusted R square is this number here, so 0.02, no, yeah, 0.027, like this. And BIF value, you need to include the highest one. So the highest one is 1, so 1.00. And then the constant, you need to check the constant here and report the unstandardized value, 6.606, with how many stars? The significance is very low, is less than 0.001. That means it's 3 stars, 3 stars here. So it's less than 0.1, yes, but it's also less than 0.05, yes, but it's also less than 0.001. So that's why it's 3 stars. Then the standard error in here is the standard error of professional aspirations. So standard error is this one, coefficient standard error, 0.134. And the standard coefficient is this one, standard coefficient beta, this one here, 0.202. How many stars? One star, because it's less than 0.1, but not less than 0.05, so only one star. That's how you report model one if you have professional aspirations. It will be different for all of us, and it will take a lot of time if I do all of them, so I will just do it for yourself. Then I think for the other model, we have it in here. I mean, it's the same thing, just report the F value that is 1.988 with one star, which is this here, and this is the significance, adjusted R square 0.181. Highest BIF value is, which is the highest, 1.395 is the highest, I think it's this one. And then blah, 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 everything. But it can take a lot of time and it can be boring. So I will just jump ahead to do the final model where we have everything. This is the big model. Where is the big model? Ah, here. This is the third model where we have everything here. We have it. So I will do that because also this final model will be the same for everyone. So I will spend the last minutes of the video. This is the end of everything. And F value is here, so 2.083, 2 stars, because it's less than 0.05, but not less than this. Adjusted R square, 0.145. BIF value, the highest one is this, 1.867. Constant is here, the unstandardized one. Here we have minus 0.004, and we have like a perfect not significance of 0.999. That's like totally what we wanted, but not a problem. We don't care about the constant. That doesn't matter for us. And the standard error of the constant, I forgot to report the standard error here, but you have to report something. The standard error, you get it just next. So it's 2.914, like this. And then let's fill in the table with all the standard coefficients, stars, and the standard errors. So for professional aspirations, for some reason we have it until the end. The, the standard coefficient is 0.118 with nothing because we don't have stars. It's very high. It's more than 0.1, so we don't have any star. Then and the coefficient and the standard error is 0.146. Then for environmental sustainability awareness, it's here, and we have the coefficient is 0.089 with nothing, no stars, and 0.166 in the standard error. Technology literacy is here the standard coefficient 0.25 like where am I? 0.275 and one star, and the coefficient, the standard error is 0.7173. Locus of control, standard coefficient 0.050, no star, and standard error 0.158. Skepticism, standard coefficient is minus 0.035, no stars because significance is too high, and standard error 1.126. For gender, we have standard coefficient negative 0.123 and no star because it's too high. The standard error 0.379. Age is 0.262 with one star, and standard error 0.082. Year, it's minus 0.159, no significance, and the standard error 0.135. University is here 0.174, no stars, and the standard error is 0.462. Level, I'm getting tired, but we're almost done. Negative 0.153, no significance. Standard error 0.401. And Sweden is 0.137, no significance. And the standard error is 0.4544. So it should look like that for everyone. Maybe I made a mistake. I'm a bit tired now, so you can also double check, but it should look like this for everyone. This will be different for each of the groups, and that's it. This will come as copy paste. I will explain in a video how to write the finding section, the quantitative part, but it's literally copy paste. Those are the tables that you need. The interpretation, I will discuss that in the video that I always upload, but good job. We have completed our analysis. It went well. I mean, we don't have the best sample, only 71 is quite low, but it's doable. So I think it's all right. The findings are fine. We have, it's good pedagogically because we had almost every possible scenario. We have full support, full reject. We have something where model fit didn't work and we have to drop that model. We have partial support, partial rejection. We had literally almost everything. So I think it's good practice in terms of learning. So that's now it. We finish. That's the end.